Okay, in the last video we have talked about um, calculating tangential force required for tractor tail when it is accelerating. Then for deacceleration we have talked about the pre-processing steps, in which we have explained that how to rate. We have created our model over here. Then we have also state defined material properties, like what will be the material properties. We have talked about some generation of mesh, that how we have generated our mesh. And from NC software what we have got is that elements will be one like 18,427 elements are in our mesh, and the mesh type is triangle. And also we have nodes over here, which is 303 and 5. So let's move to our next slide. In the next slide we are going to explain our boundary condition. As you can see here, this is our boundary condition. uh, in the boundary condition, what we have chosen is that in the middle part the force is applied. As you can see here, force is applied here on in the middle part. Similarly, and the fixed support is like our sides. As you can see here, these are our fixed support. Force is applied on this direction, and it is like tensile force is applied our this place, tensile and compressive both. So this is our force applied and fixed support. Okay, now let's move to our processing steps. In this step we have to widget the processing using software. So mostly for processing steps we use the ANSYS software, and in the ANSYS software we use a mathematical technique. So by applying a force in our in our ANSYS software, what we have got that the maximum force on which our material will be deformed is 1.01 multiplied by 10 is to power 5 Pascal. This is our force on which our material will be bent. Similarly, as you can see here, the type of force which we have applied is normal stress, and yeah, that's it. Okay, so let's move to our next slide. So here we have, sorry, oh, 1 second. As you can see here, it is not clearly seen, but I will explain it, or clearly say it using my voice. Just 1 second, so it become more clear. Okay, so for maximum bending stress, for calculating the maximum bending stress, we use length is 130 millimeter and radius is 25 millimeter. So we have to put these values in our bending stress formula, which is m by I is equal to stress by y, where this is the bending stress, I mean this is the bending stress, I is the moment of inertia, m is the maximum bending moment, and y is actually diameter by 2. For I we know that I is equal to pi r is to power 4 divided by 4. Putting the values will give us, let's zoom it. Okay, okay, now so putting the values will give us I equal to, I mean moment of inertia is equal to 3.066 multiplied by 10 is to power minus 7 m power 4. Similarly we will get y is equal to 25 millimeter. Okay, so bending moment we have got that 1.92 Newton per meter. Putting the values will give us stress, bending stress, which is 1.565 Newton per meter square. Okay, so we have calculated the maximum bending stress, which is this value. Let's move to our next part. This is the post-processing steps, and in these steps we have calculated our values from ANSYS. These values are taken from one vice stress from the ANSYS workbench with the mathematically solved, like this. As you can see here, when tractor is accelerated, when tractor is deaccelerated. As you can see here, we have taken the bending stress, bending stress analysis, analytical and ANSYS. We have calculating compare the values from ANSYS to analytical. So that's the post processing step. So let okay in these steps in ANSYS workbench, first of all we have opened our ANSYS workbench, and then we have drag static project schematic. After that we have put it all the values in here, and then we have followed all these steps step by step, and we have calculated our results. In the conclusion, now we have done this analysis, both analytical and as well as numerical on Nakalpin. Now looking into the analytical calculations like band strips which we have calculated analytically, then we have compared our analytical result with the ANSYS workbench results, which is numerical result. We have come to conclusion that our design and our result are accurate and in end is safe, so we can go for manufacture of knuckle pin which is used for tractor trailer. So this is our complete SolidWorks design for knuckle pin, and let's stop our video over here. We will see you in our next video. Please don't forget to subscribe and share our videos.